So a company runs a sports web portal that covers the latest cricket news in Australia, and solution architect responsible to manage main AWS account which has resources in multiple AWS regions, and that web portal is hosted on on-demand EC2 instances and RDS databases, so which are also deployed to other AWS regions. So IT security compliance officer has given a solution architect to the task of developing a reliable and durable logging solution to track changes made all of your EC2, IAM and RDS resources, which in all AWS region. So the solution must ensure the integrity of the log data. So which of the following solution would be the best option to choose? So first option is create new trail, AWS cloud trail with the global services option selected, and assign it to the existing S3 bucket to store the logs, create S3 ACL and enable MFA delete on the S3 bucket storing for logs, create 3 cloud trails each with its own S3 bucket to store the logs, and the third one is create new trail in cloud trail and assign it to the S3 bucket to the store the logs, and configure AWS SNS to send delivery notification of your management system, secure the S3 bucket that stores your log using IAM roles and S3 bucket policies. And the fourth one is the create a new trail in AWS cloud trail with the global services option selected, and create one of the new Amazon S3 bucket to store the logs, and creating IAM roles, S3 bucket policies, and enable MFA delete on the S3 bucket storing your logs. So for the most of the services, event are recorded in the region which the action occurred to its respective AWS cloud trail. For the global services such as AWS IAM, AWS STS, AWS CloudFront and Route 53, events are delivered to any trail that includes global services. So AWS Cloud Trail services should be on your top choice for the scenarios where the application is tracking change made by any AWS services, resources or API. So here is the Cloud Trail in the picture, and it is associated with Amazon S3 IAM role and S3 bucket policies, and above on that different AWS services is connected with the Cloud Trail. So IAM is integrated with the Cloud Trail, and the service logs AWS events made by or behalf of your AWS account, and Cloud Trail logs authenticate AWS API calls and also AWS sign-in events, and collect this event information in files that are delivered to the Amazon S3 bucket. So the correct answer is the fourth one, create a new trail in AWS Cloud Trail with the global services option selected, and create one new Amazon S3 bucket to store the logs, and create IAM roles, S3 bucket policies, and enable MFA delete on the S3 bucket storing on your logs. Second questions, a graphic designer startup is using multiple Amazon S3 bucket to store high resolution media files for their various digital artwork. After securing a partnership deal with the leading media company, the two parties shall be sharing digital resources with one another. As a part of the contract, the media company frequently performs multiple objective retrievals from the S3 buckets every day, which increase the startup's data transfer costs. So as a solution architect, what should you do to help the startup lower their operational cost? So first option is advise the media company to create the own S3 bucket, then run the AWS S3 sync and this command to copy the object for their S3 bucket to the other party S3 buckets. Second one is the enable the requester pay feature in all of the startups S3 buckets to make the media company pay the cost of the data transfer from the buckets. Third one is the create new billing account from the social media, and the fourth one is the provide a cross account access for the media company which permissions to access content in the S3 bucket. Cross account retrieval of the object S3 objects is the charge to the account that made the request. So in general, bucket owners pay for all the Amazon S3 storage and data transfer cost associated with their bucket. A bucket owner, however, can configure the bucket to be a requester pay bucket. With the requester pay bucket, the requester instead of the bucket owner pays the cost of the request that data download from the back bucket. The bucket owner always pay the cost for storing data. So here is the requester pays. Two options is here, disable and enable. So you can enable it from here. So requester will pay for the request and data transfer while requester page is enabled. Anonymous access to this bucket is disabled. So you must authenticate all requests involving request or pay bucket. The requester authenticate enables Amazon S3 to identify and charge the request for their use of their requester pays bucket. After you configure a bucket to a requester pays bucket, requester must include X Amazon request pair in their request either in the header. So for post, get and head request as a parameter in a REST request to show that they understand that they will charge for the request and the data download. So here is the correct answer is the enable the requester page feature in all the startup S3 bucket to the make the media company for pay the cost that data transfer from the buckets. So okay. Third question, a company has a several IoT enabled devices that sells them to the customer around the globe. Every 5 minutes, each IoT device send back to the data file to the includes the device status and the other information to the Amazon S3 bucket. Every midnight, a Python cron job runs from the Amazon EC2 instances to read and the process each data file on the S3 bucket and loads the values on a designated Amazon databases. So the cron job takes about the 10 minutes to process a day's worth of data. After each data file is processed, it is eventually deleted from the S3 bucket. The company wants to expedite the process and access the process data on the Amazon RDS as soon as possible. So which of the following option would you implement to achieve this requirement with the least amount of effort? So first is the increase the Amazon EC2 instances size and the spawn. For more instances, we speed up the processing the data file, set the Python script cron job schedule for 1 minute interval, further improve the access time. So let's look out the details of these questions. So the Amazon S3 notification features enables you to receive notification when certain event happen in your bucket. So to enable notification, you must first add a notification configuration that identifies the events you want Amazon S3 to publish and the destination where you want to Amazon S3 to send the notification. You store this configuration in the notification sub resources that is associated with a bucket. So Amazon S3 event notification are designed to be delivered with at least once. Typically event notification are delivered in seconds but can sometimes take a minute or longer. So here is the in picture event notification. You can just trigger it the lambda function and okay. So the currently Amazon S3 can publish notification for the following events. So new object created events. Amazon S3 supports multiple API to create objects. You can create notification when only a specific API is used. For example, S3 object create put. So or you can wildcard. So next object removal events or restore object event, reduce redundancy, storage, object lost events, replication event. So enabling notification is a bucket level operation, that is you store notification configuration information in the notification sub resource associated with a bucket. After creating a changing the bucket notification configuration, typically you need to wait 5 minutes for the changes to take effect. Amazon S3 supports the following destination where it can publish event: Amazon Simple Notification, Topic, Amazon Simple Queue Service, and AWS Lambda. So here in the question, it is asking that each IoT device send back the data file that includes a device status and other information to an Amazon S3 bucket. So every midnight Python cron job runs through the Amazon S3 EC2 instances and processes data file on the S3 buckets and loads the value designated RDS database. So the cron job takes about 10 minutes to process a day worth of data after each data file is processed. So it is there the company wants to expedite the process and access the process data to the Amazon RDS as soon as possible. So the convert the Python script cron job to AWS Lambda function here in the picture and the configure the Amazon S3 bucket event notification to trigger the Lambda function whenever an object is uploaded to the bucket. So the fourth one is the correct.